Guys, here let's look at a few problems involving what we call synthetic division, which is, as a matter of fact, one of my favorite things to do, synthetic division, but is only available to us if we are dividing by something that is a first degree divisor. So that is to say, like in our last video here, where I was dividing by something that was second degree, that would be something that we could never do with synthetic division, but must always use long division with. But for something like we had done in number 9 here, which was x to the first plus 3, because our divisor is first degree, we could actually have used synthetic division. And so that's exactly what I want to do here with these sets. So let's take a look at 17, and we'll kind of refresh our memories as to how this synthetic division works. So now, just like we do with long division, we put our dividend inside of a bar here, or an array, but you'll notice that it's an upside down bar. And recall that on the inside here, all we are including is the coefficients of our expression. So I would get a positive 2, a positive 1, and a negative 10 here. Now, on the outside, the interesting thing is that we're dividing by x minus 2. And so when we think about just, say, polynomials in general or just factorable things, remember that when we look at, say, x values, because that's what we're going to put out here is an x value, but x values that go with some factor of our polynomial. Basically, I would say that if x minus 2 were ever a factor of a polynomial, then that would only ever be true if the x value was actually equal to 2, and we could find that out just by adding 2 to both sides here. And so we'd say, well, that means that when I divide by x minus 2, I'm actually going to write x equals positive 2 on the outside here. And you don't have to write the x, but it's a good habit. Okay, and for something like 19, where I have an x plus 5 is what I'm dividing by, number 19 here, when we set it up, we would have 3, 7, and negative 20 on the inside. And I realized that I shouldn't have put 19 so close to this, but basically we would put a negative 5 on the outside of this because we're dividing by an x plus 5. Then x would actually equal negative 5. So the way this works, recall, is that we always carry down our first term here, and then we multiply diagonally, add vertically. So that is to say, we'll take 2 times this 2 here, this upper 2 times what we drop down, and so we would get 4. Now from here, what we're going to do is we're going to take whatever value that we put here, and we're going to add it to the value that's above it, so we would get 5. And then we would just go back to multiplying again, except for this time we'll take 2 times the 5, which gives us 10, and then negative 10 plus 10, which gives us 0. So a few things I want to say about this 0. First of all, you should put a box around this, and the reason why I mention this is because that is our remainder. The remainder is always the last value when we do some synthetic division, okay? Also, we took a second degree divided by a first degree, meaning that we divided one of our degrees out of the second degree, leaving behind another first degree. So what I have to tell you is, when we do synthetic division, since we divided a second degree by a first degree here, we'll be left with something that is 1 less in degree than what we started with, meaning that this being our quotient right here, the way we would put this back together is we would say that I have 2x to the first plus 5 here, and then because my remainder is 0, I suppose I would write plus 0 over the thing I was dividing by, which was actually x minus 2. And so here we have our quotient polynomial, and here we have our remainder expression right there. But essentially we have 2x plus 5 plus nothing over x minus 2. And so let's take a look at 19 here. Let's see if we get something that actually has a remainder on this one. So dropping down our first 3 here, we get 3. This is a negative 5, so negative 5 times a positive 3 is a negative 15. Negative 15 plus the 7 here would be a negative 8. And a negative 5 times a negative 8, of course, is 40. This leaves us with 20. So again, I want to put a box around this and indicate that this is our remainder right here. But the way this works is we're going to be left with something 1 less in degree than what we started with if we do synthetic division. So we took a second degree divided by a first degree. So this would be a first degree expression right here, meaning that our quotient, if we're writing it, is 3x to the first minus 8. And this is all plus 20 over the thing we were dividing by here, which is x plus 5. And so again, we do want to recognize that this is our quotient that we get right here. Our quotient is this leftover part with our synthetic division, and the very last number here is our remainder. And so we'll recognize this as well. This is our remainder expression. So what I wanted to do was actually skip over to some of these that you see on the right and look at those. There are some interesting things going on here with our synthetic division over here. So first things first, 25, say, looks like we are dividing by 5 plus x, which is just kind of a crazy thing to say, because as far as I'm concerned, this means the same thing as x plus 5. I'm always going to recommend that when we divide, okay, that we have, first of all, the thing we're dividing by in standard form. But basically, this 5 plus x here, we want the x to come before the 5 when you talk about your divisor. We usually do that. Also this, I noticed that my dividend is not in standard form, so let's rewrite it so that it is. So we have x to the fourth, actually not plus 5x to the third, this is minus 5x to the third, okay? No x's to the second, minus 5x, oh sorry, we do have an x to the second right there, plus x to the second, minus 5x. What we're missing here is a constant. And so I'm going to write that in. Basically, you want to make sure that you've got both of these written in standard form before you proceed. So looking at 25 here, 25, the way we would set this up is using our little synthetic division array here, like we do a division bar. We would drop in our coefficients of our dividend. So we have 1, negative 5. We have 1, negative 5. Wow, that's kind of fun. And 0. And on the outside here, we say, well, because x plus 5 is the thing we're dividing by, if I were to set that equal to 0, then x would actually be equal to negative 5. And so we're going to say, well, then negative 5 belongs out here. So let's go ahead and carry down our 1. We'll multiply first. Negative 5 times a positive 1 is a negative 5. Add negative 5 and negative 5, we get a negative 10. Negative 5 and a negative 10 is a positive 50. So we get 51 here. Okay, wow, this is getting interesting. And so now looking at this, we'd say negative 5 times a positive 51. Just to check this out, we get 5 and it's negative, times positive 51 here. We get negative 255, so negative 255. Now adding this, excuse me, to a negative 5, that's negative 230. If I take that times a negative 5, well, I'll definitely get a positive. And as far as I'm concerned, I suppose I would get 1,150, but I just want to show you here on my calculator so you don't think I'm crazy. We have a negative 5. So 5, and it's negative, times a negative 230. So 230, which is also negative, we get 1,150, 1150. So again, I'm just telling you, you should put a box around this last number because this is our remainder. But because we took a fourth degree here, fourth degree, and we divided by a first degree, this thing that's left over here should be a third degree. And so we definitely want to put our quotient back. We have 1x to the third minus 10x to the second plus 51x. This is minus 230, okay, plus 1150 over the thing we were dividing by, which in this case, since x is negative 5, then x plus 5 must have been the factor that we were dividing out. And so again, really quickly here, we're going to recognize that this is our quotient, this part right here is our quotient, and that this last value right here, this right here, is really our remainder polynomial. Cheers.